If you've ever ridden up a hill or walked down a flight of stairs, you know that the steepness of that hill or those stairs can play a big role. In mathematics, the steepness of a straight line's rise or fall is also crucial. In fact, it's a part of how we define the equation of a line. In this video, we are going to learn about how to calculate the slope of a line from ordered pairs, tables, and graphs. When we describe the steepness of a hill or set of stairs, we are most concerned with the vertical changes as we move forward. The same is true of straight lines on a graph. The steepness of a straight line is defined by its slope. Slope is written as a fraction. Because the vertical change is our primary concern, it will be our numerator, while the denominator will represent the horizontal change. When we calculate the slope of a line, we use 2 points from the line. In general form, we write the 2 points as x sub 1, y sub 1, and x sub 2, y sub 2. Note that the subscripts simply distinguish one x or y value from another. Because we define slope as the change in y over the change in x, the formula is m equals the difference of y sub 2 and y sub 1 over the difference of x sub 2 and x sub 1, where m is the variable representing the slope. For example, if we are using the points 2, 6 and 4, 3 to calculate the slope, we would use the substitution property of equality to write the formula as m equals the difference of 3 and 6 over the difference of 4 and 2, making our slope negative 3 over 2. We can also find the slope of a line from a table. Straight lines are in fact straight because the change in x and y is constant from one point to the next. Let's look at this table for an example. As we go down the rows in the y column, we add 4 each time. As we go down the rows in the x column, we add 1 each time. So the slope is 4 over 1, which simplifies to 4. Finally, we will look at finding the slope from the graph of a line. When we have a graph like the one shown here, we find the slope by counting the changes in y and x from one lattice point to another. Lattice points are points that lie directly on the intersection of two grid lines. We will use the 2 lattice points marked here. From one point to the next, we drop down 3 units for every 4 units that we move forward. So the slope is negative 3 over 4. We can make a few observations about what the slope of a line tells us. If the numerical slope is positive, the line goes up as it moves forward. If the numerical value of the slope is negative, the line goes down as it moves forward. Furthermore, the higher the number in a slope, the steeper the line will be. So while 2 lines with slopes of negative 4 and negative 1/2 both move downwards, the line with the slope of negative 1/2 does so much more slowly. Understanding the slope of a straight line can tell you almost everything that you might need to know about that line. In this video, we discussed how to calculate the slope of a straight line and some of the observations that we can make based on that value.